Hi everyone, this is Dr. Nauli. I'll be your instructor for the Chem 11 class, both lecture and lab that you'll be taking in the next semester. In this video, I just want to briefly describe the concept of the flipped classroom, which is something that we will be doing from the beginning to the end of the semester in Chem 11. This is a way of running the classroom that's different than your normal chemistry classroom or other classrooms that you might be used to. So I want to make sure that you have a clear expectation of what you'll need to be doing in this class throughout the entire semester. First off, I want to get you started with the class website, which is available at this address right here. So if you go to this class website, you'll see that one of the things listed on the left here is learning activities, and if you click on that, you'll see that Flipped Classroom is at the top. So I want you to click on that and open up the Flipped Classroom page. So very briefly, I will describe the Flipped Classroom in this video. I'll talk a little bit about why I'm doing it in this class specifically and what you'll be responsible for in terms of out-of-class activity as well as in-class activity. And then at the end of the video, I'll mention that there's a couple additional videos you can watch if you're still unclear about the concept of the flipped classroom. Okay, let's talk about the flipped classroom first. So a traditional classroom, right, a traditional science classroom or a traditional math classroom or any other classroom, you usually go in sitting in through a particular lecture that the instructor will give. During the lecture, the instructor might use PowerPoint. The instructor might write on the board, and then usually the instructor would work through one or two examples on the board and then have you worked out one or two examples on your own, and then afterwards you're going to be sent home to do some more practice work, which we call homework, of course, and then usually the homework is collected to make sure that you really do them. Now, what I found, I've been teaching that way for about 6-7 years now. What I found and what I've read through other research work is that that's really not an effective way of learning science. Okay, now for the instructor, for me, it's not difficult to do that. But for the students, the benefit is limited. Only about a third or a quarter of the students can learn that way. Okay? Another way to make students learn that's a lot more effective is to have a lot of hands-on activities and group activities in class. And what that translates to in a chemistry classroom is really the opportunity for you to work with your classmates to solve chemistry problems together and to share that experience with each other. So overall, the class becomes a support group where each student can help all the other students learn. That has been shown many times over in education research to be the most effective way to learn a particular knowledge set, whether it's chemistry, math, physics, or any other non-science fields. So that's where the flipped classroom concept comes along. What you'll be doing in this class, in my class, is not going to be the traditional lecture. What you'll do is, I've made a series of videos that you have to watch prior to coming into class. Where are these videos located? They're located on the website right here. So if you click to lecture topics, you'll see that there's a series of topics. If you click one of those topics, you'll be taken to this page and it will have a topic name at the top, and then if you scroll down, you'll see videos. 1 video, 2 videos, and so on. These are about 10-minute videos that I've made, and it basically contains what I used to lecture on in class. Okay? Now what you need to do is watch these videos, okay, and then take careful notes on all the concepts I mentioned in the videos. Now I know a lot of times when I ask students to take notes, they're kind of confused as far as what is good note taking, what concepts are important, what examples should they write down. So in order to help you, I've provided you with a little template in terms of outlines or concepts that you need to have down as you're watching this video. So this hopefully will help you understand what you should write down and what you shouldn't write down, because it's hard to take good notes. So this hopefully will help you take good notes. So once you finish with watching all the videos and taking all the notes, just like you would in a regular lecture, what you have to do is complete an online assignment. The online assignment is given right here. It says Chem 11 Topic 1A questionnaire. You basically just go through this questionnaire up till the end, and then at the end click submit. And then the answers that you submit will come to me, and you'll receive a copy of your answers as well in an email. That's all you have to do out of class. There's no additional homework. Watching the videos, taking down good notes, working through the online questionnaire, that's your homework. That's what you'll have to do every lecture. Prior to every lecture, if you go back to the class homepage, there's a calendar, which is shown here, and the calendar will tell you what topic is up for lecture that day. If you click on this, for example, you'll see that for the first day of meeting, we'll have topic 1A of lecture that you need to do some work on. You need to watch those videos, take the notes, and then complete that questionnaire. Okay? So that's how you know what topics you need to read up on or you need to watch on the videos. The next lecture, you can see that it says topics 1B through 1E. That means you have to watch videos in all of these topics. Okay? Okay. So now that you've done all these work outside of class, listening to these videos, watching them, taking good notes, it's sort of like you've attended lecture already. So why do you come to class still? Well, now what we're going to do in class is we're going to work on problems. Like I said earlier, research has shown that when you work in groups solving problems together and each person contributes some amount of information, whether it's good or bad information, eventually you figure out a way to solve the problem together, and that's the most effective way for you to retain that information. It's much better than me standing in front of the lecture hall just telling you how to solve that problem or telling you what the different definitions are. Okay, so in class, every time we have lecture, what we'll be doing is we're gonna first talk a little bit about the notes that you have taken, and there'll be some time for you to ask questions to each other, to me at that point. Okay, and then what you'll do after that is you'll basically just work in groups. You might work individually. There'll be some time for you to work individually. There'll be some time provided for group work. Okay, and that's what will happen every lecture time. You'll watch a series of videos, you come to class ready to work in groups and work individually, solving problems. This has been shown many times again by research to be a very effective way. In fact, there's a very high quality research that shows that when students are taught in this way, where they are asked to read a certain amount of material outside of class, and when they come in there, they work in groups to solve problems, their performance on the same test increased by about 30, almost double than the performance of students who go through traditional lecture. Okay, so that's really the reason for flipping the classroom. I want to make sure that you are learning the material so that when you move on from Santa Monica, you'll be more prepared and you'll be highly competitive in with the other students who are going to maybe compete for the same major with you. Okay? Now, the success of this flipped classroom approach, a lot of it depends on you. Your ability to set a schedule outside of class, to watch the video, and also to take good notes. And when coming into class, to be prepared to ask questions and to work with other people. It's not going to be helpful if you don't want to work with anybody, if you don't want to do any work outside of class. This is going to be a terrible semester for you. I promise you that. If that's your goal, then don't take this class. But you really want to learn chemistry, you want to understand it better, you want to be competitive with other students, I guarantee you this process works. It might seem like a lot of work at the beginning, but over time you'll find that it works much better this way than traditional lecture. Okay? Like I said earlier at the beginning of this video, there's a couple of other commentaries, videos from other universities who have done this. So this is not I'm not doing this alone on my own. There are other universities. North Carolina State is a huge university. There's a large, about 400 student psychology classroom that have used these flipped classroom approach. There's a community college math course that also has used the flipped classroom concept as well. I encourage you to read through all of these and then really kind of maybe do additional research on it, but also take a look at the rest of my website, because a lot of the learning activities listed here will discuss what we'll do in class in terms of group activity, but also how you can help yourself in solving problems. And this is, if you use this T-chart method, it will help you work through chemistry problems that you find difficult. Okay? All right. Make sure you pay attention to this video carefully, because the class will be very different than a regular chemistry class. So I hope this video gives you a good overview for what to expect on the first day of class.